Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to our panel. So today we from group 2 will present our group project which is Smart Rain Activated Clothesline Shade System. Before we go through, I would like to introduce my group members, which is the first one is Muhammad Izzuddin bin Hassan, myself, Muhammad Hafiz Azri, Amir Hakim bin Rosli, and the fourth one is Muhammad Musharraf bin Rostam, and the last one is Kuhan Rash anak lelaki Kandar Sami. So we go to the first slide, which is the first slide we tell about the introduction of this project. So the introduction of the project is the Smart Rain Activated Clothesline Shade System addresses issues with current garment drying methods, providing a cost-effective solution. It prevents the need to relocate clothes rack during rain, ensuring efficient drying and job stability. Emphasize the benefits of sun drying for cost saving and preserving clothing quality. So the next slide will tell about our problem statement, which is for our project we got two problem statement, which is in general and individual. In general, rain hampers drying, causing dampness odor garments, delaying wear, and affecting dry cleaning pickups. For the individual, clothes left all night will become cold because of the mist. Climate change will be even more crucial, especially when it comes to rainy seasons. The third problem statement is carbon dioxide emission and electricity consumption are high in dryer machine. And the last one is difficult to move the clothes rack when it's raining from one place to another. So the next slide will tell about our aims, which is our aim for this project is to create a smart rain activated clothesline shade system to improve energy efficiency or energy efficient outdoor drying and protect clothes in unfavorable weather condition. Next, the description of this project is the first final project, Smart Rain Activated Clothesline Shade System. Then we go to integrate traditional clothesline with modern tech. Next, automatically detects and protects drying clothes from rain. Arduino is used as microcontroller unit to control the overall system. Minimalist design for cost efficiency. Manual control option for user preference. And lastly, efficient laundry management in unpredictable weather.
Well, hi, and have a good day. I would like to wish to my beloved panel who are watching our group presentation with the title of Smart Rain Activated Clothesline Shade System, and we are from group 2. Well, it's time to introduce myself, and my name is Kuhan Rash Analaki Kandasamy, and my matrix number CN210335. Well, for this slide presentation of the project presentation, I will talk about two things. Number one is the objectives, and the number two is about the scopes. So moving to the first slide of my part, which is objectives. So total we have three types of three different objectives. Starting from the first one is to design and implement an automatic cloth rack that can prevent the clothes from getting wet, where this will help the user or the customer to prevent their clothes from getting wet, because nowadays we have unpleasant and unpredictable weathers, and we have to, at the same time, we have to dry our clothes using traditional methods. So this objective will really help them. Okay, second one is to design the system with using durable materials. So why? Because our product will never be indoor. It's not an indoor product, it's outdoor. We're going to keep it outside. So it must withstand unpredictable or strong weathers. For example, hot sunny day or sometimes heavy rain. So like this. So why? So when it protect, we can use this product, or the customer or the user can use this product for a longer lifespan. Worth it. So the third one is we have to enhance the precision of the rain detection sensors too accurately. Like I say, we have unpredictable weathers. Sometimes the weather changes. So our sensors will detect the perfect detection sensors. We have programmed it, so our sensor will detect those changes and will give a good output and effectiveness of this project. So moving to the second slide, which is the scopes. So total we have four different types of scopes. The first one is the mechanical scope. For example, the roller blind. So we have to retrieve the sheets. Okay, so retrieve the sheets is this electronic components will work together with the mechanical component, which is the roller blind. So to make sure the process works well. For example, if there's a rainfall detected, the roller blind will move forward to close. If the rainfall has stopped and now a sunny day, the roller blind will retrieve inside, so that will open and resume the process. So the second scope is we must make sure the roller blind really rotates 360 degrees without any problem and according to the time set. For example, for 10 seconds, so the roller blind must move for 10 seconds until it closes fully. Okay, so we must make sure the roller blind really rotates 360 degrees and without any problem in and out. Okay, so the third one is we can use all type of clothes no matter what, no any how to say we can use all types of clothes for this product. Okay, and the last one is it is limited to 8 kilo of wet clothes, so it cannot be more, then it can be less, so but you must set to 8 kilo because it will help to the effectiveness will never go, so something like that. So these are the scopes, and yeah, that's all from me. Thank you.
My name is Muhammad Izzuddin bin Hassan with metric number CN210212. Okay, for this layout design project, there are 3 roller blind which are on the top, left and right. For the back, there is also a box protection component and a place to hang cloth is under the top shutter. Next, this is the actual prototype we built. For the frame, we use wood size 1x1, and for the rail, we use PVC trunking to maintain the position of the shutter, and plastic cardboard is used to cover the control system room at the back. And it also used to be a curved bond so that the top shutter can go down smoothly. Okay, next is list of equipment that we use in this project. Okay, first we use one rain sensor, 2.3 to 6 volt dual axis TT gear motor, one Arduino Uno, one DC motor driver, one LCD display, a few of black and red wire jumper, one 12 volt DC power supply adapter, a few of jumper wire, one buzzer, two LED and one relay.
Assalamualaikum and a very good evening. My name is Muhammad Musharraf Rostam and I'm going to present and explain a little bit about the system block diagram. And for our project, we are using some main component that is contributing for our project, such as rain sensor, Arduino Uno, TTG motor, and LCD display. And first of all, for the rain sensor is a sensor that detects rain. So it can be a simple rain sensor that activates when it detects water, or more sophisticated sensor that measures rain intensity. And after that, for Arduino is our microcontroller that serves as the brain of the system. So it processes the input from the rain sensor and makes the decision based on the predefined condition. And for that, the TT motor, and for the TT motor, it is the DC motor that is a crucial component that drives the mechanism for deploying and detecting the shade of the clothesline. And for the last is the LCD, and LCD is what we want to display for the condition after the rain sensor detects the rain or whether it is rain or not raining. Okay, after that I'm going to explain a little bit more about the system flowchart. And after the start, for the initial set of our project is first the LCD will be print salam, or sometimes we could change it to hello. After that, the sensor will read the rain sensor, and after sensor read the data, so it will come into two types of condition, whether it is rain or not rain. If it is not rain, so the LCD will stay at the same, which is printing salam. And if the condition is rain, so the buzzer and the red LED will be on, that indicates that it is raining, while the green LED is going to be off. So after that, the LCD is going to display it is raining. After at the same time, the DC motor rotates forward until the shade is fully closed. And after the shade is fully closed, so the buzzer is going to be off, and the red LED also is going to be off. And the state now is the shade is fully closed. And after that, the condition will be, we are going to wait for the condition for the sensor to detect any different condition that is going to happen. But if the condition is still raining, so the shade will be still closed. But if the condition is changed, which is the condition is not rain, so green LED will be on, and the LCD is going to display no rain, and the DC motor will be rotate reverse until the shade is fully open. So after the shade is fully open, so it will back to its initial state, where the LCD will be printing salam. So after that, this is the hardware picture of our project at the outside, that where there is a circuit that we design. So we take it, we put at the back of the shed. So if you can see, there are some buzzer, Arduino, motor driver, circuit board, battery for Arduino Uno, and the relay, and 12-volt supply for the motor driver. And this circuit design is, we have solder it before we put into on the cardboard at the back of the shed. And this is for the picture when we look at the outside from the shed. So as we can see, there are LCD, push button, the potential meter that control the LED, the blue LED, and after that the green and red LED, and switch on button. And if you could see at the other side, that there is the rain sensor that will detect the rain. Okay, after that, the advantages and the capabilities. Okay, first of all, the efficient rain protection. Okay, the primary purpose of the system is to provide efficient rain protection for the clothesline by automatically deploying a shed when rain is detected. It ensures that the clothes remain dry and undamaged, and it is also reducing need for rewashing or replacing garments due to rain exposure. And for the second is integration of the technology. The system integrates modern technology such as rain sensor, microcontroller, and motor controller. So this integration enhances to overall functionality of the Clothesline shed system, making it a smart automated solution. And for the third is user-friendly operation. The system is designed for user convenience. Its automated nature means users don't have to manually cover or uncover the coastline during unexpected rain. So the optional user interface such as button or smartphone ads maybe could be could be added, so it could be a user-friendly experience by allowing manual control or adjustment setting. And after that, at the 4, adaptability. The system can be adapted to various environmental and user preferences. So it can be programmed to respond different levels of rain intensity, and some systems might even have the capability to detect the shade when the weather clears up. So this adaptability makes the system versatile and suitable for different scenarios. And for the fifth, health and hygiene. By preventing clothes from getting wet, the system contributes to maintain the health and hygiene of the user. So wet clothes can lead to discomfort and can potentially contribute to health issues. Keeping clothes dry also prevents the growth of mold and mildew, which can be harmful to both clothes and hair. And for the last is cost-effective solution. While the initial investment in a smart and activated clothesline shed system may be incurred, it can be considered a cost-effective solution in the long run. By preventing clothes from getting wet, the system reduces the frequency of rewashing or replacing the damaged clothes, saving on water, detergent, and clothing expenses over time. Okay, after that, I'm going to explain about a little bit more about our project on the safety in terms of safety, social, environmental, and economic sustainability. Okay, first of all, on the safety, preventing damp or improperly dried clothes. Okay, by automatically deploying a shade during rain, the system ensures that clothes are protected from dampness. So this helps in preventing potential health issue associated with wearing damp or improperly dried clothes, such as skin irritation and respiratory problems. So after that, eliminating the need for us to manual intervention. The system eliminates the need for us to manually cover or uncover the clothesline during the unexpected rain. Okay, this reduces the risk of accident or injuries that may occur when attempting to move a clothesline in adverse weather condition. Okay, after that, for the social, first its contribution to job stability. So the system can contribute to job stability by reducing the time and effort required for manual clothes management. That this allow individuals or this allow us to focus on the task, potentially leading to increased productivity and job stability. And after that, addressing social concerns related to weather patterns. So indigents with unpredictable weather patterns, the system address social concerns related to the inconvenience caused by sudden rain. It provides a solution that aligns with changing climate condition, making daily activities more manageable. And for the environmental, encouraging natural drying methods. So the system encourages the use of natural drying methods, which is environmentally friendly compared to electrical dryers. So by utilizing rain sensor, it optimizes the balance between natural drying and protection against rain, promoting a more sustainable approach to clothes drying. So there are potential future improvements as a technology advances. The system can be further enhanced to incorporate more sustainable materials or energy efficient components. So for example, future iterations might integrate solar powered system, making the overall environmental impact even more positive. And that, for the last is economic. Its first is providing a cost-effective solution. So the system contribute to cost saving by preventing the need for frequent rewashing or replacing of clothes due to rain damage. So users can save on water, detergent, clothing replacement costs, making it cost-effective solution in the long run. So after that, creating opportunities for market adoption and growth. So the adoption of smart rain activated clothesline chat system can create opportunities for market growth. As the awareness of the system's benefits increases, there is potential for growth in the industry. So creating the jobs and economic opportunities in manufacturing, installation, and also the maintenance of this system.
Okay, Assalamualaikum. I will explain about the test result at the slide 17. Okay, you can see from this photo, this is hardware testing before installing in the project prototype. Okay, you can see for this photo, the LCD is indicate it's raining when the wet tissue is touch the rain sensor. Okay, beside that, this is a photo of the final product, which is the description is when the rain sensor detect rain, the LCD will show it's raining and will lower the covering all area. Okay, for the next slide, also same with the recent slide, but this time when no wet tissue touch the rain sensor, it display no rain. Okay, also beside the picture is a full prototype. Nothing happened because no rain detect. Okay, you can see for this display no rain. Okay, the description when the rain sensor is not detecting, the LCD display will show no rain. Okay, next. Okay, this is a test result table. The reading record by the digital signal value of the moisture detect. Okay, you can see for this table. Okay. Also same the table, but this time is the graph. Okay, you can see the moisture collect by the sensor. Okay, day rain, day clear, night rain, and night clear. Discussion. Simulation result and actual result data is collect are the same. The timing of roller blind to retrieve and retract, which is the set, is perfect. The rain sensor is able to detect even small mist to ensure the sensitivity works well, which means we can set the sensor sensitivity from the potentiometer at the at the rain sensor. Okay, for the future improvement, okay, first, water collecting system is able to collect rainwater, so it won't be waste. Okay. Second, affordability improvement. Use component that are not so expensive. And lastly, enhanced sensor technology. Might use a nano sensor or nanotechnology on the sensor, which will decrease the effectiveness and layout design of the project.
Okay, for the conclusion, the smart rain activated clothesline chat system is a groundbreaking innovation in outdoor clothesline, seamlessly incorporating technology, particularly Arduino and rain sensor. Its automated shed deployment and retraction not only improve user convenience, but it is also enhanced safety in unpredictable weather conditions. Going beyond its primary purpose, the project holds social importance by addressing job stability concerns. It aligns with contemporary technological trends that demonstrates a harmonious balance between automation and user control.